Okay, the last thing we're going to talk about here in Article 250 grounding and bonding is a really nice clarification that they made in 250.148, connection of equipment grounding conductors to boxes. The rules for bonding metal boxes were clarified. Okay, so 250.148, continuity and attachment of equipment grounding conductors in boxes. If conductors are spliced or terminated in a box, then the following requirements must be complied with. Okay, obviously we are making splices, we are making terminations in this box, so I have to read the following requirements. Now right off the bat I can tell you this does not comply. You can't just twist the wires together and not have any sort of splicing device. That's a violation of 250.8, it's a violation of 110.14. You got to have some sort of device. So maybe a crimp sleeve on there, that would satisfy the requirement. A twist-on wire connector, push-in wire connectors. You have to have some sort of splicing device, right? If conductors are being spliced or terminated. If you just have a pull box where wires are just pulled straight through with no splices, no terminations, then you don't have to do anything. But if you're making a splice or termination, then you have to follow these requirements. There is an exception for these guys here, isolated ground receptacles. I'm not seeing a lot of IGs that much anymore because this is something that we really did a lot of back in the 80s and 90s when I was installing. And that was for alleged problems with noise, with electrical noise. I'm not going to jump down the rabbit hole here, but suffice it to say that in my opinion, I don't think these things do really much of anything. So you don't see them nearly as often because most people have come to the realization that this was probably a waste of time. The equipment grounding conductor that's allowed in 250.146D for isolated ground receptacles need not be connected to other equipment grounding conductors or to the box. All right, so if you have an isolated ground system, and that's indicated by the orange triangle right there, if you have an IG system, what that means is you would pull two equipment grounding conductors through your conduit, all right? And we used to call them one clean and one dirty. One would be green, the other would be green with a yellow stripe. And the green one we would treat just like every other equipment grounding conductor in the building, right? You'd bond it to your metal boxes and everything else, and that green with a yellow stripe would go straight from the exo terminal of the transformer, no connections, right to the receptacle's grounding terminal, okay? Not something we really do anymore, but that's what the exception's talking about. All equipment grounding conductors that are terminated or spliced in the box must be connected to each other. All right, that was the clarification that was made here in the 2023 code, and it's a clarification that we needed. So here is the issue. Looking at this picture, and I took this picture, and this used to drive me insane as an inspector. I've got two three-way switches here. The one on the left is wired where we bring in, the hot and the neutral, bring in the hot and the neutral, and then we take the two travelers over to the two travelers in the neutral, and then switch leg and neutral out to the light. So we connect the equipment grounding conductors of the two cables together, right? The hot and neutral and then the travelers. We connect those two together, splice them up, pigtail it out to the switch. This one over here is a dead-end three-way, right? Where we just have the two travelers and the two travelers and the switch leg, right? So black and red, white conductor, right? There you go. Phase tape the white in accordance with 200.7, and then you've got the equipment grounding conductor for it. And if you'll notice, that equipment grounding conductor is not connected to the other two equipment grounding conductors on the left-hand side of the box. Is that a violation or not? Well, under the 2023, absolutely, that is a violation. If you're splicing in that box, all of them need to be spliced together. Previous versions of the code, you could easily argue that that was not the case. All right, so now it's very clear they have to be spliced together. Here's the thing. Looking at this, is this really unsafe the way it's done? I mean, really, this equipment ground on the right is going to the switch yoke and going back to the panel. So if this traveler or this switch leg ever made contact with the yoke, it would energize it, travel back on the equipment ground, 1,000 amp current, trip the breaker, perfectly safe, right? Well, what if one of these hot conductors on the left had a fault and energized the switch on the right? Could that happen? Absolutely. You're pushing those wires back. Maybe you're a little too fast when you were stripping them and you nicked one of the wire insulations, right? And you stuffed them all together and that wire made contact with the yoke of the other switch. That could absolutely happen. What would happen in that instance? The hot conductor from a cable on the left would energize the switch on the right, and the fault current would have to travel back on the equipment ground in the cable on the right. So that cable on the right, the equipment grounding conductor would become energized, but the ungrounded conductor in that cable would only be carrying the load current, right? Like a half amp or whatever. And then suddenly you got 1,000 amps on the equipment ground. Well, when you have 1,000 amps on the equipment ground during a fault, you need that equipment ground to be in the same cable as the faulted conductor, because it's got that massive expanding collapsing magnetic field, right, of 1,000 amps. You need the hot conductor and the equipment grounding conductor to be right next to each other so that while one magnetic field is expanding, the other one is collapsing and canceling out. Otherwise, that equipment grounding conductor is going to suffer what we call self-impedance. All right, we're going to have a massive amount of current on it without an adjacent conductor to counter the effects of that massive electromagnetic field. So it's important that all of these things are spliced together. Now, by splicing these two equipment grounds to the one on the right, it wouldn't matter which cable energized which switch. The fault current would travel back on both of those equipment grounding conductors, cancel the magnetic field out. We wouldn't have to worry about self-impedance. It would trip the breaker, and we'd all live happily ever after. So, in my opinion, very good change. We keep reading. It says connections and splices must be made with identified fitting. Yep, we talked about that. Can't just, twist the wires together and call it a day. Metal boxes, a connection that serves no other purpose, must be made between the equipment grounding conductor and the metal box. So here on the left, you got your bonding screw, twist your equipment grounding conductor around it, tighten it up, good to go, right? Does this screw have to be green? No, it does not. It does not. That is going the wrong way, right? That screw probably ought to be going the other way, so when you twist it, it tightens the wire. Over here, good to go, right? This is a switch, as you can see. Do you have to run the equipment grounding conductor actually to the switch yoke? Well, if it's a plastic box, you sure do. But if it's a metal box, take a look at 404.9b. You might be surprised at what you don't have to do to bond a switch. The last thing, if a bonding jumper is used, all right, so we splice our equipment grounding conductors right inside these cables, splice them all together, and then we're going to put a bonding jumper out there, pigtail, to go to the receptacle. How do you size that pigtail? Well, how do you think? You size it based off the rating of the breaker, right? You size it the same way you size the equipment grounding conductors in the cable. But if the code doesn't say, then the code doesn't say. So, if a bonding jumper is used, it must be sized using 250.122 based on the highest rated overcurrent device for the conductor in the box. There you go. Size it just like you know you would. So there you go. We made it through Article 250. Hope to see you on the other side when we start talking about Article 300, which is my other favorite code article, General Requirements for Wiring Methods and Materials. See you then.